Okay, so today we're going to take a look at pandas. So this is like super important as far as data science, data analysis goes. Pandas really just powers a lot of basically data manipulation and data analysis. So our first 3 weeks were spent kind of getting familiar with other stuff. Like the first week was on Git. And then weeks 2 and 3 were just on Python and NumPy, okay? And so I'm hoping we at least have the basics of Python and NumPy down, and now we can get into Pandas, okay? So Pandas is built on top of NumPy arrays, okay? And we create basically data frames, okay? And so data frames allow us to have structure in our data, but data of different types. Okay, so NumPy, one of the strengths and weaknesses of NumPy is that their arrays must all contain data of the same type. Okay, it's a strength because that speeds up all sorts of calculations, but it's a weakness because you can't have integers in one column and floats in another column and strings in another column. That breaks the whole thing down. So with NumPy, everything has to be of the same type. Pandas allows us to have each column hold a different type, okay? Each column is set up as a series, which is kind of built on top of a NumPy array. And so your series, your column will, if you think about your column being variables, and each row being an observation, this is your traditional tidy format, it makes sense that the columns will all be restricted to the same data type, okay? Much like in R, when you set up a data frame, it's a list of vectors. Each vector will be of the same data type, but because it's, you got a list of different vectors, you can have different things. Okay, so anyway, you load up pandas by saying import pandas as PD. So NumPy is NP and pandas is PD. And that just saves us a few keystrokes when we get into the pandas library, okay? And again, the most basic data structure is the pandas series. Generally in pandas, you're going to be working almost entirely with data frames, but it's important that you understand the individual column, which is the pandas series, okay? Because all of the functions that you apply to data frames, oftentimes you'll call out just one column, and that column is always going to be a series object, so we have to kind of be familiar with a series object, okay? So anyway, here I'm going to create a series object by doing pandas pd.series, capital S series, and then here I'm providing it a list of 4 values, okay? And then, and when I do that, when you print out the data here, let me, so Jupyter does some interesting stuff, okay? So anyway, so you print out data and it looks like this. If you just call data, it prints out the same thing. If we ask for the type, it reports back that it is a pandas core.series.series. Okay, so it's a class of series. The series also contains the D type. So in this case, float integers, because again, series are pretty much NumPy arrays with just kind of some index values attached to it. Okay, so here we've got 0.25, 0.5, 0.75, and 1.0. And that creates my series. If I ask for data.values, okay, we get a NumPy array, and if I ask for the type of data.values, indeed it is a NumPy array, okay? The series obviously is printing out differently from the NumPy array, and we can see that when we create a series object, it attaches indices. It attaches an index to each of these values, okay? Which is how it kind of keeps all of your rows tied together. Okay, so these 4 values are an array, a NumPy array, but when it's a series, there's definitely going to be an index. Okay, you can pull out the index itself of data. Okay, so the data has 4 values, and they are the NumPy array. And you can see when you pull out the index, it gives you basically a range object. Okay, a range index, which is part of what Pandas does, and it starts at 0, ends at 4. Okay, and when we're talking about range objects in Python, 0, 4 really ends up at 3, right? Because the last data point is last value is not included. All right, you can subset a series just like you normally would. Okay, and so here I ask for the value at index 1, and I get 0.5, and this is not a array, and it's not a series object. It is just the number 0.5, and so it's a float 64. Okay, so when you pull something out, it will simplify the object. Okay, if you're only pulling out one value. Okay, whereas I can slice it, and I can say go from 1 to 3. So this will pull out the 2 middle values, 0.5 and 0.75, and we can see that because I've pulled out multiple values here, it remains as a series object. Okay, is that all right? So when you're pulling out one value, it simplifies it to just the value. If you're pulling out multiple values, it retains its structure as a series object. Okay, so in NumPy, you are able to do fancy indexing, and you can do the same with the series. So I'm subsetting series, and I'm saying give me the objects at index 1, 0, and 2, and so it gives you the values at 1, 0, and 2. Okay, again, this is going to be a series. When you create the series, by default, the index will be a range index starting at 0 with the length of its values. But you can also specify your own index. Okay, so in our case, I'm going to use the letters A, B, C, D as an index, and if I do that, I get this. Okay, so contrast. So here, 0.25, 0.5, 0.75, 1.0, and the indices are A, B, C, D. Let me just. So here, maybe I should have named it something else. But anyway, so data.values is it capital? I can't remember. Oops. Okay, so data.values is still a NumPy array. And then data.index, okay, you get back an index class, and it has the letters A, B, C, D. Okay, so here I've got the series, okay, where the indices are A, B, C, D, and the values are 0.25, 0.5, 0.75, and 1. Okay, so in this case, you can subset data with the index position, or you can subset with the index name. Okay, when we were back here where the indices were the kind of the automatically created integers, we can only subset using the well, the index position is equal to the index name. Okay, and just like before, you can slice using indices. So slicing from 0:2 will choose the values, the first two values here. You can also slice with index names, but it does something different in that it will include the last value. Okay, so slicing from A to C will go will return A, B, and C. Okay, whereas normal index slicing won't do that. Okay, so here I've created, you can create a dictionary and then create a series based on the dictionary, okay? And if you do that, then the dictionary keys will become the index, and then the dictionary values will become the values, okay? So here you can see, just making some stuff up. I think these are, I looked at the actor heights from Riverdale. Anyway, okay, so Archie apparently is 5'11", so 71 inches, and Betty is 5'6" and 66. And anyway, okay, so I wasted time doing that, but I've created this dictionary here. Okay, so we got the key with the character name and the index being the value being the height. Okay, so we can pull out and we can see that the series.index is the list of names basically, but as an index object. Okay, and then the sample series dot values are still a NumPy array. Okay, so the dictionary is a dictionary, but then when you put it into pd.series to convert the dictionary into series, you get that as well. Okay. And over here, here's another dictionary with the actors' names, and we have that. Okay. So now I have two series. I've got a series for heights, and I have series for actors, and so from that I can create a data frame. Okay, and here I'm creating a dictionary of series objects. Maybe I should say the dictionary key becomes the column name. The dictionary values become the values, and let's see. And then the keys within the dictionary, within the dictionaries. I should say the dictionary the dictionary values become the values. Okay, and the keys within the dictionaries become the indices. Okay, so here we have, a series with indexes: Archie, Betty, Veronica, Jughead, Cheryl, and so it will match up those things. So over here in this series, the order of the index is different, right? So up here it's Archie, Betty, Veronica, and over here it's Archie, Jughead, Betty. But when we create the data frame, it matches the data up accordingly. Okay, and when we create the data frame, it defaults to alphabetizing the indexes, or ordering them in sorting them in some form. Okay. Let me just write that out. The data frame will match the indices and sort them. Okay, and then if we ask, what do we have? Then it tells me it is a Pandas data frame. Right? There's other ways to create data frames. All right, we're only going to get through like this much. And so here you can provide it a list of dictionaries. Okay, so here I've got dictionary where key A is 0 and B is 0, key A is 1 and B is 2, and key A is 2 and B is 5. Okay, so this is a list of dictionaries, and what this will do is it'll create a data frame where the keys become the column names, okay, and then because no I did specify an index. It creates an index over here. Okay, and the values in the dictionary become the values. Here I'm doing the exact same code, except I just changed this thing, the last character in this dictionary, to a C. Okay, and so this dictionary has keys A and B, this dictionary has keys A and B, and this dictionary has keys A and C. And so if I put that into a Pandas data frame, it's going to try to match up the values, and it's going to say this dictionary doesn't have a key for B. And so it's going to put in a missing value. And then it's going to see that we've got a key for C, so it's going to create a column for C, and it's going to say these dictionaries don't have C's, so it's going to put missing values for those. Okay, so we have missing for the C column in the first two rows, and a missing for the B column in the last row. Okay, if the index argument is not supplied, it defaults to integer index starting at 0. Okay. And then the other way of kind of manually creating a data frame is you can give it a dictionary, and you give it the key names, which will become the column names, and then you give it a list of values. So A will have the values 1, 2, 3, and B will have the values X, Y, and Z. Okay, so I've got a dictionary, keys, and then the values are lists of values, and it will form the data frame as such there. Okay, you can also just take any kind of NumPy array. Okay, so here is just a random integer arranged 5 by 2. Okay, and so we can just take this array and throw it into data frame, but you'll want to specify the names of the columns, and you can choose to specify the names of the index. Okay, and if you do that, it will do that just like that here. Okay, we're out of time, so we'll take a look at all this other stuff I guess on Wednesday.